for the Q&A section to ask questions. If you have more complex questions, you can send them to conferenceroom@ocrim.com. You can also listen to the webinar in different languages. You can select the interpreting service. You can listen to the webinar in English, French, and Spanish, or in the original Italian. So I'll leave the floor now to Paolo that will talk about the topic that I've already mentioned. Please, Paolo, the floor is yours. Thank you very much, Paula. Welcome, everybody, and good morning, good afternoon, or good evening, according to the place in the world where you are right now. Today, we would like to explain some of the experimental and concept projects that we are currently testing so that technologies in artificial intelligence can help us improving plant performances. So the question that you're reading on the screen is the first question that I would like to ask today. Can artificial intelligence improve plant performances? The answer will be yes. Yes, but artificial intelligence alone can do very little, and we'll try and understand why. Because artificial intelligence is one or more than one algorithms that when they're not fueled correctly, if they don't have the correct input, they can't work properly. The most crucial thing in terms of artificial intelligence is data. So being able to access data and data sharing, the objective is having a non-invasive artificial intelligence. So not an artificial intelligence that would replace human beings, but an artificial intelligence that is able to support human beings. And in this context, I would like to quote T.S. Eliot, a very well-known author, when he said, "Where is the wisdom we have lost in knowledge, and where is the knowledge we have lost in information?" So our objective is transforming data into knowledge, or information rather. So I've added this question: where is the information that we have lost in the data? So data is the pillar around which everything in artificial intelligence revolves around. So data are crucial because they allow us having at our disposal the necessary information so the artificial intelligence algorithm can work. So we need to think of artificial intelligence algorithms as muscles that need oxygen and fuel in order to strengthen and improve. So we need strong algorithms and fine-tuned, efficient, enhanced artificial intelligence algorithms. So training is crucial, but also validation and testing, because after training, the algorithms must be tested on separate data sets to ensure that they work correctly and to evaluate their performance. And to do that, we need to check and evaluate the data that we are using. So we need also to have a continuous update of data. So we need to be open to new data, updating regularly the algorithms, because without the fuel that fuels the muscle of artificial intelligence, we could encounter problems, or the artificial intelligence algorithm will be limited. So Ocrim has already launched an instrument, a tool that allows us collecting and managing data that is generated by the milling plant. So it's extremely important having this tool that allows us the collection of data, but also sort data according to their quality. So we need to be able to identify what are the best data, the data that we want to use to fuel artificial intelligence, and unnecessary data or data that are related to the inventory or to the stock present in the plant. Secondly, we need to find bias in data, so unnecessary, wrong, superfluous, redundant data that might lead to false positives. So we need to sort and filter all the data and separate necessary and unnecessary data, of course. And thirdly, and lastly, we need scalability. That means being able to have a system that can host this whole set of data. So in this context, for our vision, once the manufacturing execution system, our tool, can take data that are generated from the plant, then it's able to upload this data into a structure that we are implementing right now in Ocrim, which is the cloud system. Of course, this cloud relies on cloud technology, and it also complies with all standards of cybersecurity and privacy. So this is very helpful so that we can have a large archive through which we can train our artificial intelligence tools. So let's look at the data type that our production software can provide us with. So we have data that is related to raw materials or products and stocks, data that are related to recipes for production, so recipes for flours or milling recipes or mixes of different grains. We have then data that are related to cycles, so production tasks that need to be carried out during a whole day in the plant so that the milling process is as efficient as possible. Data is also related to maintenance. We'll be talking about that shortly. All the reports also, so reports that are related to energy consumption, reports that are related to deliveries and shipping, so all kinds of reports. These are all data that are necessary to or are very useful to develop artificial intelligence tools. All this data can be then uploaded or exported towards first level softwares like ERPs. This is the corporate first stage software. So we can use our MIS, exporting all these data in the slide into the ERP software. So let's now talk about more concrete things. So we are working currently on an application that is called Advanced Production Planner. What that is, this is a tool that allows us to optimize planning of processing cycles in the milling plant. So we put together different kind of data, so data related to recipes, to production cycles, and energy consumption data, together with the energy cost that can be also subdivided into the cost of energy throughout the day. Putting together all these data, we get a planner, an advanced production planner. So let's take a look at an example. So we have the management admin desk here with the list of the different tasks, processing tasks that have been planned throughout a 24 hours day. So time scalability also, it's modifiable, so we can also apply this system to a 48-hour time frame. So we have the first result, the ideal sequence of tasks that should be carried out every hour. Once the artificial intelligence tool is launched, we have a change or a recalculation of the different tasks throughout the days according to the energy costs. And we can also include different levels of priority in this schedule. So different milling procedures can be assigned to a different level of priority, and the artificial intelligence tool plans the day accordingly. Of course, this is flexible. It is non-binding for the operator. It's just a support that the operator can benefit from whenever he's planning his day. So summarizing, the objective of the Advanced Production Planner is to maximize production, minimizing downtime or changing processing procedures, improving the planning schedule, and also at the same time being able to plan maintenance schedules and labor availability. So we can set some maintenance time frames so we can focus activity in the plant and having an optimized production plan. Another good thing is having real-time monitoring of the plant. In terms of maintenance, the second project that we are working on right now is the predictive maintenance tool. This is a midterm objective of ours. In this case, we are putting together different data, maintenance tasks, working time, and the list of the alarm
il tempo di lavoro di ciascuna macchina e la lista degli allarmi che il sistema SCADA PLC fornisce
that is provided by the system. So we put all these data into the AI algorithm. Our objective would be getting to a maintenance predictive tool that is effective. Let's look at this graph now. I'll show you the curves of maintenance. So in this drop at the end of the curve, we see the reactive maintenance. So this is maintenance that is carried out whenever there is failure, so repair after failure in case of irregular vibrations, noise, high temperatures, smoke, or even the destruction or the damaging of the machinery. If we need to stop production and act on the department that is undergoing this problem. Of course, this creates an unplanned and undesirable stop of production in the plant, and that creates problem. Of course, this is the worst case scenario. Currently, thanks to our production software manager, we are able to ensure preventive maintenance. This means that for different groups of machinery, the working time and the countdown on machinery, we have planned a whole array of maintenance tasks that need to be carried out in a preventive way in order to ensure the good functioning of every single component, every single machinery in the plant. So doing so, whether we're talking about greasing, cleaning, or other more invasive interventions, we are able to ensure the efficiency of the plant. But of course, we need to be honest here. We are running the risk with preventive maintenance. We're running the risk of carrying out maintenance activities that are unnecessary, maybe. So we are changing bearings, for example, in a machine that doesn't really need that replacement in that very moment. So we try and base ourselves on case histories, on the chronology and the on the history of the plant, and so we do preventive maintenance. What we want to get to is predictive maintenance. What is this? This means training an algorithm that collects data, putting together the alarm list, the maintenance tasks that have already been scheduled, and data that come from the field, from the plant, so that through this tool we can intervene when we have the slightest signal that machinery needs maintenance. So this is focused and specific maintenance that is done over specific machines that really need it. This is our objective with artificial intelligence. This is a mid-term objective, and we are sure that we're able to get there. So summarizing, this is an example of what our production management software is already doing. So for every single machinery piece produced by Ocrim, we have a task database that need to be carried out by the operator. And through this list, we ensure the good functioning of the whole milling plant and the whole production process. On our software, we also have all the online manuals of our machinery. So everything is online. So if an operator needs some information whenever he or she is carrying out maintenance on the machine and he or she needs some additional information to carry out the operation correctly. So putting together these tasks and the alarm list that can go off in the plant allow us to train the algorithm so that we can plan maintenance activity that are the most precise possible. And we want to do this because we want to focus different maintenance. So we want to have a proactive maintenance strategy. We want to reduce the maintenance downtime so as to improve production. We also want to enhance maintenance activities when they're needed. So we want to avoid replacing components that are still in good health. And lastly, we also want to enhance our stock and warehouse, so having a set of components and spare parts that are really needed. Talking about spare parts, I'd like to remind you that you can access to the Ocrim portal on the marketplace, in which you can buy all your spare parts directly online. So this is the second application that we're working on that is related to artificial intelligence. The third project that we are launching right now is the automation virtual assistant. This is a non-invasive application that aims at supporting production. So we want to support the operator whenever there's alarm going off, or if there are solutions that could be adopted in order to reduce energy consumption. We want this virtual assistant to suggest preventive maintenance tasks to the operator. And also, we would like to create diagnostics and simulations. So, for example, once we set some settings for processing, instead of launching production directly from our software, management software, it would be nice having a simulation or a first projection of the final result in terms of yield, milling, processing of the product through this application. So this could be a very useful support to the operator. And of course, we don't want it to replace the operator. We just want to be a support. This was an overview of what we are working on, the concepts and the missions, objectives that we want to get to related to artificial intelligence. I hope that you found my presentation interesting, and thank you very much for your attention.
Grazie Paolo, abbiamo un paio
Very
di
good. So thank you very much, Paolo.
un po'
We have a
sulla
couple questions.
sulla di quella che
Um,
era già nel
the first one
nel
is
precedente webinar
very
che abbiamo
similar to a
fatto.
question that
Volevo
was
soltanto
asked
un
this
attimo, una
morning.
chiacchierata
but I'll read now a second question. So the operators will need a specific certification or specialization. Would you support them in that? What do you think? Well, operators won't need specific training. We will organize the classical training like how we are doing currently. There will just be a slight extension to the training so that operators are able to use this tool that will allow also the operator to be autonomous. So this will be a non-invasive tool, and that means that it doesn't require specific skills from the operator. So there won't be any additional burden on training for the operator, apart from what is really needed whenever we ask operators to use our software manager tool, and maybe some additional information, but nothing too difficult or too specific. In the past, you've talked about your own cloud. Are you working on that? Do you know when this project will be launched? We are working on it. Technology is moving forward at a very high pace, so we would like to try and find the best solution possible so as to implement it as soon as possible. So we don't want to settle with the temporary solution that in 2 years' time won't be scalable and applicable. So we are looking at Aruba or Azure by Microsoft. We are trying to understand what is the best service, first of all, in terms of security, and secondly, in terms of longevity and performance. Earlier, you've talked about Atmil. Can you please tell us if this software, this Atmil software, could be useful in developing AI applications? Yes, it's crucial actually. Atmil is crucial because it's an open door to the data that we need, so that we are able to collect the data we need, so that we can fuel and input this data into AI tools. Okay, very good. I think we can wrap up our webinar. Again, if you have some further question, you can send your question to conferenceroom@ocrim.com. You can, well, please be tuned with us on our social channel and networks and our website to follow our news and for future webinars that will be organized and to be updated through our pages and newsletters. Thank you very much for your attention and have a wonderful afternoon.
Grazie.
Grazie,
you.
buona serata.
Thank you very much. Have a nice evening.